today we're talking about Interlaken, and I would like to tell you a little bit about its purpose and history and how it evolved from XAUI and SPI. So in 2006, back then, if you remember, XAUI was sort of limited in the amount of lanes it could support, and it was sort of like meant for streaming of or sending serialized data, but it didn't have features like flow control or channelization or things like that. So the lackings of XAUI led two companies. It was Cisco and I'm falling short on the name. They formed a committee to find the perfect solution for the problem and came up with Interlaken. And Interlaken sort of took the best of both worlds and merged serializing of data with SPIs, flow control, and channelization. So Interlaken can support multiple channels, so data is interleaved from different sources onto the same links, and it has some pushback features for for doing flow control basically, but also is using high-speed serial lanes, so it minimizes the amount of pins that are required to transfer the data. So that was the base of the standard, and with years going by, the committee introduced extensions to the standard. The first one was actually a look-aside extension, which was basically a simpler version of the protocol. So it didn't really provide as many channels, but the burst could be shorter and was very good for talking to devices like a look-aside coprocessor or things like that, or sending short commands over the protocol. And look-aside is not really compatible with base Interlaken. It's like a lightweight version. You can think of it as a lightweight version of Interlaken. Then in 2010, they introduced the retransmit extension, which basically allowed the protocol to handle data failures on the links. So if data was deemed erroneous by failing a CRC check, the receiver could ask the transmitter to send the data again and recover from the error without involving the top-level sort of CPU or upper-level control features of the design. So it was sort of handling it on its own. Another extension for dual calendar, and this has to deal with flow control. So it introduced a second set of flow control sort of configuration, which you could change while the other one was running. And you could re-provision channel bandwidth or change priorities and things like that with that. And finally, recently in 2016, well, maybe not so recently, but they introduced the RSpec extension, which is basically a read Solomon forward error correction. And this was sort of introduced because of PAM4 signaling and the bit error rates that are associated with PAM4. So to help the bit error rate, the RSpec encoding or forward error correction is sort of fixing errors on the stream and improving the bit error rates to a usable above 10 to the minus or below 10 to the minus 15 ratio, right? And this is important when you're using PAM4 signaling over NRZ, because that is inherently like much poorer quality because of the 4 levels of signaling.